This is AP Psychology, Chapter 10.4, Thinking in Language. We left off talking about language development. Children learn their native languages much before learning to add 2 plus 2. We learn on average after age 1, 3,500 words, a year amassing 60,000 words by the time we graduate from high school. So we're going to talk about how we trace the course of language acquisition from the babbling stage through two-word stage. Children's language development mirrors language structure by moving this from simplicity to complexity. Beginning at about 4 months, infants enter the babbling stage in which spontaneously utter various sounds at first unrelated to the household language. By about 10 months, a trained ear can identify language of the household by listening to an infant's babbling. Around the first birthday, most children enter the one-word stage, and by their second birthday, they are uttering two-word sentences. This two-word stage is characterized by telegraphic speech. This soon leads to the uttering of longer phrases. There seems to be no three-word stage. And by elementary school, they understand complex sentences. So babbling stage begins at 4 months. The spontaneous utterings of various sounds like ah, goo, ma, da. Babbling is not imitation of adult speech. It is merely just noises that they make. When do we learn language? The one-word stage begins at around the first birthday. Starts to speak one word at a time and is able to make family members understand him or her. The word doggy may mean look at the dog out there. The two-word stage, before the second year, a child starts to speak in two-word sentences. This form of speech is called telegraphic speech because the child speaks like a telegram. Go car means I would like to go for a ride in the car. Longer phrases. After telegraphic speech, children begin uttering longer phrases. Mommy get ball. With syntactical sense, and by early elementary school, they're employing humor. You never starve in the desert because of all the sand which is there. So when do we learn language? Here, this is a chart. At approximately 4 months, babbles speech sounds. At 10 months, babbling resembles household language. At 12 months, one-word stage begins. By 24 months, two-word telegraphic speech begins, and at past 2 years, language develops into complex sentences. So, explaining language development, we're going to discuss Skinner's and Chomsky's contributions to the nature-nurture debate over how children acquire language, and explain why statistical learning and critical periods are important concepts in children's language and learning. The debate between behaviorist view of malleable organism and the view that each organism becomes biologically prepared to learn certain associations surfaces again in theories of language development. Representing the nurture side of the argument, behaviorist B.F. Skinner argued that we learn language by familiar principles of association of sights of things with sounds, imitation of words, and syntax modeled by others, and reinforcement with success, smiles, and hugs after saying something right. Challenging this claim and representing the nature side of the debate, Noam Chomsky notes that the children are biologically prepared to learn words and use grammar. They were born with what Chomsky called a language acquisition device already in place. So in operant learning, Skinner believed that language development may be explained on the basis of learning principles such as association, imitation, and reinforcement, where inborn universal grammar is Chomsky's idea, who opposed Skinner's idea and suggested that the rate of language acquisition is so fast that it cannot be explained through learning principles that most of us must principles, and thus most of it is inborn. Chomsky calls his language acquisition device as already being in place, and he argues that children acquire untaught words and grammar at too fast a rate to be explained solely by learning principles. Moreover, there is a universal grammar that underlies all human language. Cognitive neuroscientists suggest that this statistical learning that occurs during life's first few years is critical of the mastery of grammar. Skinner's emphasis on the learning helps explain how infants acquire their language as they interact with others. Chomsky's emphasis on our built-in readiness to learn grammar helps explain why preschoolers acquire language so readily and use grammar so well. Nature and nurture work together. So statistical learning in critical periods well before our first birthday, our brains are discerning word breaks by statistically analyzing which syllables in hap, t, e, b go together. These statistical analyses are learned during critical periods of a child's development. Genes in the brain. Genes design the mechanisms for language, and experience modifies the brain. Language and age. Learning new languages gets harder with age. The older you are, the more difficult it is to learn that second language. That's why many two-language homes, the children will develop their ability to speak a language, say English, here in America, and they may have very little, if any, accent at all, while their parents who learned English while at an older age still maintain a heavy accent throughout their life. Language and thinking are intricately entwined. Sometimes language seems to interfere with thought, although we are often advised to talk through a problem. Jonathan Schooler and his colleagues reported that verbalization can actually interfere with insight to problem solving. All right, so consider this problem. A giant inverted steel pyramid is perfectly balanced on its point. Any movement of the pyramid will cause it to topple over. Underneath the pyramid is a $100 bill. How would you remove the bills without disturbing the pyramid? The insight is the bill can be removed by destroying it, that is, by tearing it, burning it, etc. The obstacle is that we think only in terms of preserving the bill. When research participants were asked by Schooler and his colleagues to do this, solving a series of insight problems, they actually solved 30% fewer problems than those who were not asked to explain themselves. Investigators speculate that the verbalization may cause non-reportable aspects of a task to become overshadowed by those that are more readily reported. Solutions to insight problems occur suddenly, suggesting that critical steps leading to the solution are unavailable for conscious inspection. It's the same kind of paralysis through analysis that you find in sports context. When you start becoming reflective about the process, it undermines your ability. You lose the flow. There are certain kinds of fluid, intuitive, nonverbal experiences that are vulnerable to this process. In contrast, verbalization would not be expected to interfere with the non-insight problems because they involve a series of incremental steps, each of which is separately reportable. In fact, verbalization may facilitate our solving those types of problems. Okay, now we're going to summarize Worf's linguistic determinism hypothesis and comment on its standing in the contemporary psychology. Linguistic determinism by Worf suggested that the language determines the way in which we think. For example, he noted that the Hopi people do not have a past tense for verbs. Therefore, the Hopi cannot think readily about the past. Although Worf's linguistic determinism hypothesis suggests that language determines thought, it is more accurate to say that the language influences thought. Language expresses our thoughts, and different languages can embody different ways of thinking. Many bilinguals report that they have different sense of self depending on which language they use. At the same time, those without our words for shapes and colors perceive them much as we do. Given the subtle influence of words on thinking, we ought to choose our words carefully. Studies of the effects of generic pronoun he and the ability of the vocabulary enrichment to enhance thinking reveal the influence of words. Some ideas, such as the ability to perceive and remember different colors, do not depend on language. We might say that our thinking influences our language, which then affects our thoughts. When language provides words for objects or events, we can think of these objects more clearly and remember them. It is easier to think about two colors with two different names than colors with the same name. Increasing word power pays its dividends. It pays for speakers and deaf individuals who learn sign language. Linguistic determinism. Although people from Papua New Guinea do not use our words for colors and shapes, they still perceive them as we do. To a large extent, thinking is a language-based. When alone, we may talk to ourselves. However, we also think in images. We often think in images, in remembering how we do things. For example, turning on the water in the bathroom, we use procedural memory, mental pictures of how we do it. Artists, composers, poets, and mathematicians, athletes, and scientists all find images to be helpful. Researchers have found that thinking in images is especially useful for mentally practicing upcoming events that can actually increase our skills. We do not think in words when we open the hot water tap, when we're riding our bicycle. Images, imagining a physical activity activates the same brain regions as when actually performing the activity. Traffic runs both ways between language and thinking. And animals and languages. Do animals have a language? Honeybees communicate by dancing. The dance moves clearly indicate the direction of the nectar. Common cognitive skills in humans and apes include the following: concept formation, insight, problem solving, culture, and mind.